In this video, we are going to find the derivative of these 14 functions. So first, take a moment and see whether you can find the derivative of these functions. And then what you can do is you can compare your solutions, your answers with the solutions discussed in this video. Yeah, so this is a moment you can stop the video and try to solve these problems on your own first. This is the part 2 of the chain rule video. So please watch this video after watching the part 1, which solve some easy problems. So in this video, we're going to try to solve difficult problems. We're going to find the derivative of difficult functions. So what difficult means, there are multiple steps in these functions. So there are like a multiple component functions. So what we normally do is we need to figure out what is the chain of functions. So you can start looking at the chain. When you say a chain, the order matters. What comes first matters. So let's try to understand that first, and then we can look at a real problem. So let's look at the chain of functions. So when you look at the chain of functions, we're gonna follow an argument outside in argument. So what we're gonna do, we're gonna start outside. So it is outside and then inside argument. So what does that mean? We're going to start with the most outer function and then go to the most inner function because that's the chain. So it will be very clear if you look at a problem. So let's look at this one. So let's look at y equal square root x squared plus 1. So you can rewrite this one as x squared plus 1 to the 1/2 power squared 1/2 power. So we can write the chain now. So if you look at the most outside function, and you can see that it's clearly the square root function. So the outer function, so you can write as fx equal square root. So it is, if you gonna use a u, so it is square root function. That's the most outer function. And then next you're gonna go to the next inside function. So you can see that the next function is x squared plus 1. So that is the chain we are talking about. So first one is square root function. The second one is x squared plus 1 function. So let's look at another one. So we have y equal square root x squared sine squared x plus 1. So you can rewrite this one as square root sine x squared plus 1. So you can see that there are three functions here. So if you look at the first one, so first one is the square root function. So you can start with the first one, so which is the square root function. So as the first function, as before, we have fx, which is the square root function. So you can just write it like that. And then we have the gx, the second function. So after square, then you're going to go inside. So you can see what you have is something squared plus 1. And then as the most inner function, you can see that you have sine x. So what matters is just the form of the function. That's why we did not write a variable here, because what matters is fx is square root, second one is something squared plus 1, third one is, last one you have to write because that's the last function, which is sine x. So that's the chain we need. So let's look at one more example. Actually, before we discuss that, and you can see that this is not unique. This is not the only way to write it. There are multiple ways to write this one, but this is one of the obvious way to look at the chain. So let's look at another one now. So we have a y equal e to the tan inverse e to the x. So we have, so what's the chain now? So you can see most outer function is ex. So we have fx equal e to something. And then the second function is after e, you can see that the next one is tan inverse. So we have gx. That's the second function, which is tan inverse something. And then the next one is h, so you can call it h, so which is e to the x. So we have e to the x. I write x for the, because other function, it doesn't really matter what is in there. So that's why we just write it like just a bracket. So that's the chain for that one. So let's look at one last one. How about this? So we have y equal sine e to the tan inverse square root 1 minus x squared, and then you can see that there are 5 different functions in the chain. So we can start with the most outer one. So I just write the function now. So the first function is sine something, and then after we pass a sign, then you're going to go to e. So we have e to something, and then the next one after e, you're going to see tan inverse. So tan inverse. Some people write this arctan. It's the same thing. And then the next one is square root. So we have square root function. And then finally, you can write as 1 minus x squared. So you can also write the last step as 1 plus x and then minus x squared. But this is also okay to write it this much quicker. So there are 5 components in this chain. So that is the chain you need to understand, because once you understand this chain, it's very easy to write the derivative. So we can write the derivative in each step for the corresponding function. So it's very clear what is the function is. And you can see that you can match this with when we try to find the answer for this one, you can see whether how it works. So now let's try to look at the list of the problems that we're going to do. So let's look at the practice problems. So what the theory says that every time you're going to multiply by the derivative of the next inside function. So every time multiply by the derivative of the next inside function in the chain. So let's look at the first example. We have y equal cube root of 4x to the 6th minus 3x squared plus 7. So we know that we can write this as using a power. So it is 4x to the 6th minus 3x squared plus 7 to the 1/3 power. Cube root means 1/3 power. So the base function is u to the 1/3. So that is the base function. So that means, and then also we can use the power rule here. That's the main tool. So it's a derivative of x to the n equal n x n minus 1. So now let's start writing the derivative of the chain. So so the first one is the cube root in the chain. So the next one is the degree 6 polynomial inside. So that's the second term in sense. There are 2 terms in this chain. So the y prime is, so if you look at the first function in the chain, which is the 1/3 function, so it is 1/3, whatever the function inside, no change to that function, and then you're going to multiply, so it's 1/3, and then you subtract 1 from the power, so that means it's going to be negative 2/3. So we're done with the first function, and then multiply by the derivative of the next inside function. So that means we're going to multiply by the derivative of that. So since it's the first example, I'm going to write it like that. So it's a derivative of that function. So it's a prime notation for the derivative. Okay, so then we can take the derivative as we discussed. So it's 1/3, 4x squared minus 3x squared plus 7 to the negative 2/3. And then you can see if you take the derivative, we're going to multiply the two numbers. So it is 24 x to the 5th power minus, again you multiply the two numbers. So that means negative 6x, and then the constant, so derivative is 0. So that's what you get. Now what we can do, we can simplify if possible, and you can see this is 3, so you can cancel 3 of this, so it's become 8, and 3 of that. So you have to cancel 3 from each term, okay, because you remove the common factor. So that's what you get. Now we can write this using positive index. We never leave negative index in the final answer. So you have to rewrite this using positive index. So that means we can write this one as 8x to the 5th minus 2 x minus 2x, and divided by, we have 4x to the 6th minus 3x squared plus 7. So we have 2/3 power. 2/3 power means you take the square first and then take the cube root. That's what it means. Okay, so that's the final answer for this one. So let's look at the next one. So as the next example, we have y equals sine cube 4x minus 1, And then we know that we write the power in between the function just to avoid confusion. That means if you rewrite this in the power form, so we can write this one as sine 4x minus 1 to the, so we can write the we can write like that. That's third power. So that means you can see here the base function is something to the cube. So it's a u cube is the base function. So that means if you look at the chain in this case, you can see the first one is a cube function. So something to the cube. And then if you go to the next one inside, and then you can see that next one inside is a sine function. So that's a sine, so that's the second function. And then the third function, and you can see that the third function is 4x minus 1. So that is the chain. So there are three functions in the chain. So now let's see how we use. So what we do every time you multiply by the derivative of the next inside function. That's how we do. So in this case y prime is, so this is the cube, so that means 3, and then whatever you have here, so we're going to repeat the function without any changes. So the inside function is a sine 4x minus 1, that's the inside function, to the it's 3, so it becomes 2 times the derivative of the next inside function. So the next inside function was sine 4x minus 1. That's what happened. Okay, so that means 3. So we can repeat this, sine 4x minus 1 squared. Actually, you can put this 2 in between, like here. Yeah. And then, so now what we do, we're going to multiply the derivative of this one. And then if you look at this one, and you can see the next inside function is this. Okay, so this is a sine function. So it's a sine function. That means the derivative is cosine, whatever the function, and then multiply by the derivative of the next inside function. The next inside function is 4x minus 1. So that's what happened. Every time you multiply by the derivative of the next inside function in the chain. Okay, the chain has cube sine 4x minus 1. Okay, so finally we're going to get 3. So this is sine, I'm going to put 2 here now, 4x minus 1, and then we have cosine 4x minus 1. So you don't need to use parentheses here because it's very clear what the function is. We only use parentheses when there's a confusion. So there's no confusion here, and it's clear that what is the function here. Okay, so cosine comes after sine. Okay, and then derivative of 4x minus 1 is 4. Now what we can do, we can simplify this if possible. You can do is what you can do, you can multiply these two numbers. That's the only thing you can really do here. So that means your final answer is 12, and then you can write this one as sine squared 4x minus 1 times cosine 4x minus 1. And you really don't need any other extra parentheses here. So that's the final answer. Okay, let's look at the next one. So we have y equals sine 4x minus 3. So then here you can see that you cube the inner function, not the sine function. So you have to be very careful with the difference between the two. So we do not need any extra parentheses. So let's write the chain first. So if you write the chain, you can see that the first most outer function is the sine function. So sine something, and then you're going to go to the next inside function. So what's the next inside function, or the argument of sine is, you can see it is a cube function. So the next one is a cube function, and then you go inside the cube function, and then you can see that you see 4x minus 1. So that is the chain now. So you can see this chain switch from the last time. Okay, so now we can write the final answer. So we can, I'm going to write this directly now. So you can see there are, so it's not that difficult. So it is y prime. So we can start with the most outer function, which is the cosine derivative of sine, which is cosine whatever the inside function. So I'm going to repeat this or change to the function, and then derivative of the next inside function. The next inside function is 4x minus 1 to the cube. That's the next inside function. So this is the next inside function. Okay, so that means the cosine 4x minus 1 to the cube, and the derivative of this one is 3 4x minus 1 to the square from the power rule, and then again multiply by the next inside function. So the next inside function is this. So which is 4x minus 1. So that means we write all of them. So you're going to cosine 4x minus 1 cube, and then we have 3 4x minus 1 squared, and then we have 4 here. So final answer is so you're going to get that 4 3 and 4, so you're going to get 12, and then you're going to get this time I'm going to write the x term first. So we have 4x minus 1 squared, and then we have cosine 4x minus 1 to the cube. So that is the final answer. And you can see that this answer is completely different from the previous one. So that means the order matters. Okay, so let's look at the next one. So we have fx equal 3x minus 1 over 3x plus 1 whole thing square root. So that means you can see, you can rewrite this one as before, 3x minus 1 over 3x plus 1 to the 1 half. And we put this question in this list not because this is really difficult problem, but this is like lengthy problems. You can see this is like little lengthy. And then so you can see the base function is square root. So that's a base function. Okay, so so it's very clear what the chain is. We have a square root, and then we have the quotient. So and that's it. So we can use the quotient rule for this one. So if prime x is, if you use the base function, most outer function which is the square root function is a 1 half, whatever inside, no change, 3x minus 1 over 3x plus 1 to the negative 1 half, and then multiply by the derivative of the inner function, which is 3x minus 1 over 3x plus 1. Do we need a parenthesis for this one? No, because it's very clear. So sometimes you put unnecessary parentheses, so and that also going to complicate the situation. But if you really need it, you can put, but you really don't need a parenthesis here, because the quotient is just one quantity. If there's a product, you have to, but quotient you don't have to. Okay, so let's try to write something, how we write something properly in mathematics. Okay, so good. But if you really need, you can put a parenthesis there. Okay, so and then we know the quotient rule. So if you have a quotient, the derivative of the quotient is v comes first, and then so u over v comes first. Remember that v comes first before u. That's the easy way to remember this one. V first before u. So v u prime, and there's a minus sign. Why minus sign? The order matters. Whether it's a u top or v top it does matter. So that's why there's a negative sign here. And then we switch the order. It is a u v prime over v squared. Okay, so it's easy way to remember this one is v comes first. Okay, so we're gonna use the formula and write them now. So we have 1 half, and then 3x minus 1 to the 3x plus 1 1 half, negative 1 half. So we don't do anything, and then take the derivative here. So so that means we can write this one as, so the v comes first, that means 3x plus 1 comes first, and then multiply by the derivative of the v, the u, which is 3 minus 3x minus 1 times the derivative of v, which is again 3 over v squared, which is 3x plus 1 squared. So we can simplify this a little bit. So you can see that now what I'm going to do, I'm going to rewrite this one as 3x minus 1 to negative 1 half, and 3x plus 1 to negative 1 half, because you can see that you're going to use that in the simplification. On the top what will happen, you're going to say 3x times 3, which is 9x, and again 3x times 3, which is 9x, but there's some negative sign, that means it's going to get cancelled out. So and then what's going to happen is we have a 3, and you can also see that there's a 3 and a negative sign, so that means negative 3, and with the negative is going to be positive, so it's going to be 6. So you're going to get 6 over you can see it is 3x plus 1 to the squared. Okay, now we can simplify this a little bit. You can see it's going to cancel out with 3 remaining. So that means you find, and also there are some simplification that you can do, and you can see you can combine these two. That means we have a 2 minus 1 half, so which is 3 halves. And then also you can bring the negative power down, so that means your final answer, you can write this one as, we have 3, and you can see we can write this one as 3x minus 1, to the, you can see it is 1 half, and then the other one is 3x plus 1, it is 3 halves, so I'm going to put 3 here and take the half, that means square root of the whole thing. So that's the final answer for this problem. So let's look at the next one. So as the next one we have y equal tan inverse sine theta. So we have an inverse function here. So let's recall the derivative. So we know the derivative of tan inverse or the arctan is simply 1 over 1 plus x squared. So that means if you use that, and then what will happen here is, you can see the chain is, we're going to start with tan inverse, and that's the first function, and then it's going to go to sine. So that's the second function. So let's try the derivative now. Y prime equal, so it's a tan inverse, so that means 1 over 1 plus something squared, so it is sine theta squared. That's the first function, and then multiply by the derivative of the second function, which is sine theta prime. We know the sine theta has the derivative cosine theta, so that means the final answer is cosine theta divided by 1 plus, and you can see sine, we can write this one as sine square theta. Whenever you have a trigonometric function, you want to see whether you can simplify this further than that, and it's very clear that you cannot simplify this further. So that's the final answer. So let's look at the next one. So as the next one, we have y equal to 2 to the power negative t ln t. So that's a product. That's a product, and also we have 2 to a constant to a power other than the exponent e. So let's recall the derivatives now. So we're going to use, so we have few derivatives here. The first one is, we know that the d by dx ex is just ex, but that doesn't happen with any other base. So if we have some other base like b base, so what will happen, it is b to the x, no change, and then we have to multiply by the derivative of the you need to multiply by the log of the base b. So you have to multiply by ln b here, just a constant. And then we also use the derivative of natural log, and we know the natural log x is just 1 of x. Even this result works for absolute value, because ln has to be, the argument has to be positive. So so those are the functions that we can use here. So let's try the derivative now. So it is y prime equal, so and then you can see in the chain what we have is 2 to something, that's the base function, and then the product. So that means you're gonna according to the formula, you have to repeat the function and then multiply by the derivative of the inside function, which is negative t ln t. So then we can write the final answer, it is 2 to the negative t ln t, no change, and then we can multiply by the derivative here. So so we have to use the product rule, so uv, and then again what's the product rule, so we have uv prime, which is, you can write the first one, so it is uv prime plus vu prime, and you can see that there's a plus sign here. The reason is the order doesn't matter, so that's why there's a plus sign here. In the quotient rule there's a minus sign, but the order does matter. Okay, so if you use the product rule, so you can see that actually what else we can do is we can actually pull the negative sign out. So I'm going to write the negative sign out. So without negative sign it's much simpler. So we have a t, and the derivative of ln t is 1 over t, and then plus, because we pull the negative sign out, so it's over there, and then we have ln t, and then multiply with the derivative of t, which is 1. And then you can see that these two get cancelled, so you get a 1 here, so this simply becomes 1. So that means finally you're going to get negative, you can see 2, and the negative t ln t, and times, you can see it is 1 plus ln t. So that's the answer. And if you need the final answer with a positive index, you can say negative 1 plus ln t, and then you can say 2 to the t ln t. We normally write final answers with positive index, except when we have e functions. E functions we normally leave negative index there. Okay, especially in the numerator. Okay, let's look at the next one. So we have a very interesting function gd equal e to the negative 2t cosine 3d. This function are very important in STEM courses like this. You can appear in engineering, differential equations, physics, biology, chemistry, everywhere. So let's see how to find the derivative of this function, because it's a so common function. And you can see that this is a product. So we have a u and a v. So that means we need the product rule again. So it is we know that it is the uv prime and vu prime. And then also you can write this on a vu prime plus uv prime, then it's going to follow the same pattern as the quotient rule. So it's easy to remember. So you can write this as vu prime, now is a minus uv prime over v squared. So you can remember one of the versions. So you can see the difference in this. One has a plus, one has a minus, the other one has a minus, same term in the top except the sign change and then v squared. So that's the only difference. So yeah, you can remember this version if you want. Okay, so I'm going to use this version here for this problem. So the g prime t is, you can see vu prime and then uv prime. So you can see that it is cosine 3t, that's the v, and then multiply by the derivative of u, so which is e to the negative 2t times negative 2 plus. So we can remember there's a you can write this one as another formula. So if you need the derivative of e to the constant x is simply the constant times e to the kx. So this will be very useful later. So if you have e to the constant times x, it is constant comes out and then e to the kx. So it's again a like application of chain rule. So that's so now the first term, now let's uv prime. So that means u is simply e to the negative 2t and the v prime. So v means in this case cosine. So the derivative of cosine is negative sine 3t. See, since you have a negative sign, you have to use a parenthesis here. Okay, otherwise what you write is if you don't write the parenthesis is wrong. Okay, and then multiply by the derivative of the inside function, which is 3. So now finally we can combine all of them, and you can see e to the 2t is common, so we can pull it out. And also you can see both have a negative sign, so I can pull negative e to the negative 2t out as a term, and then the leftovers from the first one is 2 cosine 3t, and the leftovers from the second one is 3 sine 3t. Okay, so that is the final answer for that problem. So it's not that difficult, but it goes through several different derivatives. Okay, let's look at the next one. So now let's look at problems which are a little bit difficult. So let's see what happens if there are 3 terms in the chain. So as the first one, we can look at this one. So we have y equal e to the tan inverse ex. So if you look at the chain, you can see the first function is e to something, and then the second one is the tan inverse, and then the third one is e to the x. So that's the chain. So here we use the exponential function. So let's recall the formula for exponential function. That means if we have e to a function, the derivative is e to the function, no change, times the derivative of the inside function. So this is so we discussed these kind of problems in the 3 formula video. So if you are not familiar, and you can look at the video, so you can find the link in the description. So let's see how we can take the derivative now. So it is y prime equal, so it's e to a function, that means you repeat the function, and then multiply by the derivative of the next inside function. And as you can see that it is the derivative of the tan inverse ex, because that is the next inside function. And you don't need a parenthesis here because the tan inverse that function, so there should be a argument, so you don't need a special bracket here. So now if you take the derivative, so what will happen is e, so we have tan inverse ex, and if you take the derivative, we know tan inverse derivative, it is, so the derivative of tan inverse is simply 1 over 1 plus x squared, so that means it's simply going to be 1 over 1 plus, in this case x is simply ex, so that means it's going to be ex squared, and then again multiply by the derivative of the next inside function, which is ex. So finally you're going to get we have e to the x, and then e to the x, and then we have e to the tan inverse ex, and in the bottom you can see that 1 plus e to the ex squared means e to the 2x. So this is not done here. You can see we have these two exponents, you can combine them into one, so finally we can write the answer as e x plus tan inverse ex divided by 1 plus e to the 2x as the final answer. So it's not complicated, but there are extra steps here. Okay, so let's look at the next one. So as the next one, we have y equals sine inverse natural log square root x. So let's see the chain now. So you can see the first we have sine inverse, and then we have ln, and then we have square root x. So that's the chain. And then what's the derivative of sine inverse? So we take the derivative of sine inverse, which is 1 over 1 minus x squared square root. So that means we can write the derivative now. So it is y prime equal to 1 over 1 minus the inside function. Here the inside function is square root x whole thing squared square root, and then times the derivative of the next function. So the derivative of the next function is, so next function is ln, and we know the derivative of ln. So derivative of ln x is 1 over x. So that means whatever the inside function gonna go down. So it is that, and then you're gonna multiply by the derivative of the next one. The next one is square root function. The derivative of that is 1/2 x to the negative 1/2. So that's what you get. So every time you multiply by the derivative of the next inside function, and if you combine all of them, and you can see the answer is 1 over, you can see that 2, because if you bring the square negative 1/2 down, so you get with the square root get 1 just x, and then we have 1 minus ln square root x whole thing squared, and then take the square root. So that's the answer for that. Okay, so let's look at the next one. As the next problem, we have y equal cosine squared ln 3x. So be careful, like, what this really means. So you can see that we have ln 3x. So the way we write ln 3x like act as one function. So if there's a confusion, you can put a parenthesis there. So you should be able to read how what is the actual function is. So sometimes, so there's like a special terminology when we use parentheses, when we do not use parentheses. So if it is a confusion, you can put an extra parenthesis there. So now we know that this is actually according to trigonometry. This really means you take the cosine, and then we have natural log 3x, and then the whole thing squared. That's what this means. So that means your first function is u squared. So u is the inside function. So if you look at the chain now, so what's the chain? So you can see, so squared is the first function, and then it's going to go to the next function after square. Next function is cosine, and then the next function is ln, and then finally we have 3x. So that's the chain. So we have 4 functions in the chain. So then we can write the derivative directly. So that means the derivative is y prime equal, first one is the square, so that means 2, and then whatever we have, so it is the cosine part. So it's since it's the first power, so we don't need the parentheses, so it's cosine, and then ln 3x. So that's the first function, and then we're going to multiply by the derivative of the inside function. So the inside function is cosine now. So that means the derivative is negative sine, and then you can see ln 3x. And then, so we're done with the second function, and the third function. Third function is this one, ln. So ln means we know the derivative of ln, which is 1 over. So that means it is 1 over. The function is 3x. So the next one is next inside function 3x. So that means the derivative of 3x is 3. So that is the derivatives we have. And then you can see there are some simplification. For example, 3 and 3 get cancelled. So that means finally we normally write the negative sign in front, and then we have 1 over x, so we can write it like that. And then you can see so there is a 2 here. So that means we're gonna get so you can write the 2 here. So 2, and then sine. So what you have is a cosine ln 3x, and then we have sine ln 3x. That's what we have, and then you can see that you can actually combine these two into one. So we remember one of the identity from trigonometry, which says that sine 2 times theta equals to 2 sine theta cosine theta. That means 2 sine theta cosine theta, you can bring it back to one term. So what will happen is you double the angle. So that means because of that, we can rewrite this one taking 2 in, simply 1 over x. You can write this one as sine, and then you double what is inside. So you can see it is 2 times ln 3x. So so that's what you get. So that's the answer for the derivative after simplification. Okay, so let's look at the next one. As the next one, we have y equal 2 to the negative t squared log base 5 1 minus 2t. So let's recall what is the derivative of a log function when we have other bases. So when you have log base let's say a or base b, then what will happen is we simply do this like ln, so that you get 1 over x, but you have divided by extra ln b. So that's the derivative. You have divided by ln b. When you have exponential function, you multiply by ln b. When you have log, you divide by ln b. Okay, so so let's try. So and then you can see that there's a product here. So we have a u and a v. So you have to use the product rule first. So if you use the product rule, so y prime equals, so there'll be a lot of writing here. So it is we can write the take the derivative of the first function. So the derivative of the first function, or this is a log function. So that means the we recall this one. So that means we have b to the x. So the derivative of b to the x you can repeat, and then you multiply by ln b. So we can use that here. So that means it is 2 to the negative t squared, no change, and then multiply by the derivative of the inside function, which is negative 2t. And then we repeat the second function without any changes. And then plus the second term, so we repeat u. So what we have only u prime v, that's what we wrote, u prime v. Now we can write u v prime. The other one. So that means it is 2 to the negative t squared, and then we need to multiply by the derivative of the log function. So the derivative of the log function is, we know that, so if you recall that also, if you have a ln fx, it is simply you write the fx in the denominator and then f prime x on the top. So that is the derivative of a log, even with absolute sign. So even if you put absolute sign, it's the same thing. So that means according to that, so you're gonna get, so you write the function down. So the function is 1 minus 2t, and then multiply by the derivative of the function. This is negative 2, and then also, since this is not ln, you have to divide by ln 5. So that's according to formula. Okay, so finally, and you can see that this term is common. So when you have exponential function, that always happen. So that is common, so you're going to pull it out. And also you can see there's a negative sign everywhere, so they're going to pull the negative sign out. So what you get, the leftovers are, so you can see from the first one, you're going to get t, and then we have, actually we noticed that we forgot one term, because when you take the derivative of an exponential function, we have this ln b terms that we forgot. That means there should be extra ln2 term from the first, because the base is not e, its base is 2. So that means the answer going to be t ln2, and then we have log base 5, 1 minus 2t, and then we have plus, because we pull that out. So you're gonna get, we took 2 out, so which is 1 minus 2t times, you divide by ln 5. So that is the answer for the derivative. So let's look at the next one. As the next one, we have hx equal secant inverse sine e to the negative x. And you can see that you don't need extra parentheses here, because there's only one function, e to the negative x. So it's clear that that's the only function we have. So there's no confusion. So there's something you need to learn, like when to use the parentheses and when not to use the parentheses. Okay, so we need the derivative of the secant function, and let's recall that. So we know the derivative of the secant is, so secant inverse is 1 over absolute value of x, x squared minus 1. So you may have used a version without the absolute sign. That depends on what branch you use when to define the inverse function. So the way we did it, because we try to find the branch that is closest to 0. So when you do that, you need the absolute sign for that. So you may have used a different branch, so like a branch like little far away. In that version, you don't need the absolute sign. So please refer to what version you use when you define the inverse function. Okay, so let's continue. So let's look at the chain first. So what are the chain here? So you can see, so the first one in the chain is secant. So we have secant inverse function, and then if you go inside, so you can see it is the sine function, and then we have e to the negative x. As one piece you can write, or you can say ex and then negative x. So but we can go with three chains, three pieces in the chain. So now we can write the derivative directly. So the first one is, you can see it's the inverse function, secant inverse. So that means according to the formula, it should be 1 over, you can see we take the absolute value, so it is absolute value sine e to the negative x, and then we're gonna square, and then so we know that when you write the square, you write square here, and then e to the negative x, and then minus 1. So that's the derivative of the secant, and then you need to multiply by the derivative of the inside function. Inside function is this one. So derivative is a sine, so derivative is cosine, no change, and then you multiply by the derivative of the e to the negative x. So that's the next inside function. So you can see it is e to the negative x times negative 1. So that's the derivative. So what we can do, we can write them in a nice way. So what we can do is we can write the negative sign in front, and then we write e to the negative x as the next one, and then we have cosine e to the negative x, and then the whole thing divided by sine e to the negative x, and then sine squared e to the negative x negative 1. So so that's what you get. And then you can see that you really don't need the absolute sign here, because you can see that e to the negative x is less than 1. So you can see this is in between 0 and 1. So you can ignore that, because sign 1 is positive. So in that case, you can actually ignore the absolute sign and write the final answer without the absolute sign. So I let you do that. Okay, let's look at the next one. As the next one, we have a very interesting function. We have y equals sine e to the tan inverse square root 1 minus x squared. So it can be a little complicated. Let's look at the chain now. So if you look at the chain, it may be clear like this, not that bad. So we're going to start with sine, that's the first one. And then you can see it is e, a function. And then we have tan inverse. And then finally we have 1 minus x squared square root. Actually, you can write the next one as the square root without x. We don't write x because it doesn't really matter. So we write the square root, and then we have 1 minus x squared. So that is the chain we have. So we have 5 functions in this chain. So let's try to write the derivative one by one. So we have y prime is sine, that means the cosine. Whatever inside, no change. Every time we don't change the inside function, it just stays there without any changes. Every time you do that. So we're done with the first one. And then the exponential function. If it's the exponential function, we repeat the exponential function, whatever you have, no change, and then multiply by the derivative of the inside function. In this case, inside function is this one. So which is tan inverse. You know the derivative of tan inverse. It is 1 over x squared plus 1. X means here tan squared. So so in this case, derivative of tan inverse is 1 over x squared, but here x is simply 1 minus x squared square root. So that means we have 1 minus x squared square root. You square that plus 1, and then finally we're going to multiply by the derivative of the inside function, that's the square root function. So it is we have a 1/2, and then we have 1 minus x squared to negative 1/2. Finally, you're going to multiply this one by the derivative of the inside function of that, which is negative 2x. So if you combine all of them, finally you're going to get the answer as, so you can see what we have here is, so you can say negative, there's a negative sign from the last one, and there's x term. So we have x, and then we have e to the tan inverse 1 minus x squared square root, and then we have the cosine term e to the tan inverse 1 minus x squared square root, and the whole thing divided by, and you can see when you there's a simplification here. So when you square root get cancelled out, so you can add the two, so you're gonna get 2 minus x squared. So you're gonna get 2 minus x squared, and then finally you have the square root term 1 minus x squared square root. Since you can see this 2 and the 2 get cancelled out, so that is the answer to the problem. So it's not, I mean, so you have 5 different functions there, so you can 5 different derivatives. Okay, so that's the answer for that question. So let's look at the last one. So as the last one, we have y equal cosine cube tan inverse e to the x squared, and you can see that this parenthesis is not really needed because there's only one function. So the chain is very clear. It is the so what's the first one? And you can see the first one is the cube. So we normally write bracket cube, and then the next one is the cosine, and the next one is the tan inverse, and then e to the x, and then x squared. So that's the chain. So we can write the derivative like this. See whether you get this as a derivative, and then you can finally write the answer like this. Now try the following problems as practice problems.